So here is the syllabus. First page is a lot of words. Things to be highlighted here. Things that you need. You need your lab manual from last semester. Okay, so you still get to use the same lab manual. So we gave you a lab manual that was for 2 courses instead of just 1. So you've got that already. You need a new lab notebook if you have used more than 20 pages of the current lab notebook that you're in, or if you started a new notebook last semester and you used less than 20 pages, you can keep going with that notebook this semester. Okay. The sections here are, like I was telling you, my section Tuesday morning is the only Tuesday section, and then we've got 3 of them on Thursday. So we've got Dr. Gilmore Thursday morning, we've got Dr. Gilmore Thursday afternoon, and then Dr. Peterson is teaching 4A on Thursday afternoon, and that is the section that doesn't have a complementary 4B. So if you're interested in doing the independent project, and you're registered for 4A, you will end up doing the project with me. For that, I'm doing it Thursday afternoon when we get to the second half of the semester. Okay. So basically, all the Thursday afternoon people that want to do a project will funnel into one course for that. Okay. Chem 255, which was last semester's lab, and 221 first semester lecture are prerequisites for the course, and then your co-requisite is organic lecture, being enrolled in that. Okay. We'll talk briefly about some of these things as we go along, looking at the schedule, like when the final exam or midterm exam is, quizzes are, and then just make sure that you turn things in on time, otherwise they'll be penalized 10% for each day that it's late. So I'm going to jump ahead to the schedule because then it makes a little more sense when we're talking about dates. Just like last semester, on the left-hand side, we've got the day you're doing things in lab. On the left-hand side for the Tuesday and the Thursday sections, we have 5 quizzes this semester, okay? And so last semester you had 11 and you dropped 1 and 10 counted. This semester we've got short half semester going very quickly, all 5 count, okay? So make sure you're in lab on time, ready to go to take the quiz so you don't miss any that way, and make sure each week that you've prepared for the quiz, because starting next week, each week that you meet, there will be a quiz, all right? So it says for this current week, we've got experiment 16 and experiment 18. The actual doing is experiment 18, and that's what you're going to do your pre-lab for. There's no pre-lab for experiment 16, and like I said, that's just a series of worksheets that you can start on now if you'd like to. And then next week we will go on to experiment 17 for 2 weeks, and then our last experiment is 3 weeks. It's a 3-part experiment. And then we get down to Monday, February 24th, and instead of a final exam for this course, we have a midterm exam, and so it'll be given on Monday the 24th in this time slot. So at 4 o'clock on Monday the 24th, you'll all gather together at the same time for the midterm exam. So just make sure you've got that on your calendar, okay? And then we've got this kind of in-between week. Those of you taking the lab for just the A portion, we'll check out of your drawers those continuing on with the B portion, then we'll keep going with that, okay? And then all of your due dates are here on the left, on the right. And the first one that I highlighted is in 2 weeks. Experiment 18 and 16 are due. And then as we go along, I'll highlight the rest of the due dates, okay? So the points for the course are broken down into, we've got lab notebook, and then like the exercise for experiment 16. So that's 250 points. There's the midterm exam, since it's only half the semester, is 50 points, not 100 points. And the weekly quizzes, there's 5 at 10 points each, so that's 50 points. And then the lab safety and technique, because it's for half the semester, is 25 points instead of worth 50 points. So there's 375 points possible for the lab this semester. As far as lab safety is concerned, Chem 255 is a prerequisite for 256A and 256B. So The same safety rules we went through all last semester will be followed in lab this semester. Appropriate dress, make sure you have your safety glasses on, you know, working in the hood, not working outside of the hood. All of the things that we went through last semester all still pertain to this semester. If you didn't take lab last semester, make sure your instructor knows so that they can make sure that you are on top of all of the safety information, all right? Same lab rules as we went through last semester. No phones or earbuds in your ears are allowed. No food or drink, anything like that is all, you know, also not allowed in the labs. And like the safety rules in, you know, during your scheduled lab are the same as the safety rules during open lab time. For your lab notebooks, the same guidelines that you used for last semester pertain to this semester, even though you may have switched instructors in the course of things. So if you have questions about lab notebooks, I would talk to your specific instructor if you have specific questions, but basically the same layout and all of that we went through last semester also pertains to this semester, okay? So at the end today, I'll talk about the pieces of the pre-lab. The pre-lab is still the same thing, but the pieces that you'll need for experiment 18. Disability and accessibility resources. If you feel like you are in a situation where you need to reach out to DAR or the ASC, the information is here for that, and then I would encourage you to also work with your instructor for those situations. Academic integrity, basically make sure that your work is your own work, so there's no questioning of where the information came from, and then you will be all set. There will be, just like we kind of, experiment 14, we pulled data. At the end of experiment 20, we'll pull data, but make sure that it's just the data that's being shared and not everything else that's being shared. And then course evaluation. At the end of the first half of the semester, there will be evaluation of the course, evaluation of teaching, and all of that sort of thing at the end of the course. So that is the syllabus as quick as I can go with all of the highlights covered. Questions you guys have with that? Okay. And you guys, you'll have your paper copy, and then I'll have, it'll be up on Moodle all semester. I won't take it down, so if you need to access it at any time, it'll be up there for you as well, okay? So what I'm going to do now is I am going to go through experiment 18, couple different formats. We're going to start with PowerPoint, but then we're going to go to where we need to work out some information as well. I'm going to leave this up while we are going through the PowerPoint part, because this is basically your flow chart that you need to use for experiment 18. So this is in your lab manual, and this is the flow chart that you're going to use for your pre-lab, all right? So experiment 18, you have an unknown similar to what you had with experiment 6. So everyone's going to get a different unknown, and then it's your job to figure out what unknown you have. We're going to go about it with some similarities to experiment 6, but also some differences. There's two basic categories for the types of unknowns that we're going to look at. Those that are containing oxygen, and then those that are containing nitrogen. So the first group, the oxygen containing groups, we are going to, you could potentially have an alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, or an ester, all right? On the flow chart, basically what happens with the flow chart is if you have an oxygen containing group, you follow the flow chart. If you have a nitrogen containing group, you've got another set of rules that you're going to follow, okay? And I'll tell you here in a little bit how you're going to know what you have from the information that you give it, okay? So I'll work through this flow chart, but basically, kind of like experiment 6, the alkanes were the functional group that you got a negative test for everything. when you work through this flow chart, the group up there that is the negative for everything is the ethers, okay? So if you get all the way through the bottom of this flow chart and don't get any positive results, then most likely you have an ether, unless you were told you had a nitrogen, and you shouldn't be working on the flow chart, okay? The other groups, the nitrogen-containing groups then, we've got a possibility of an amine, an amide, a nitrile, and a nitro compound. Now, what is a possibility in either the oxygen groups or the nitrogen groups is you could potentially have two of those groups, but we won't be so mean as to say you have an oxygen group and a nitrogen group, because that'll totally throw you off, because you won't follow one part of the flow chart if you think you don't need to, okay? So keep in mind that it is a possibility that you have multiple of those groups in there. The other possibilities are that you will have either an alkene, an alkyne, an arrow ring, or a halide in there. So if you remember from last semester, with the alkenes and alkynes, how would you know if you had one or not? Do you remember from experiment 6 how you would know if you had an alkene or alkyne? Potassium permanganate test, and what other test? And the bromine test. So you needed both of those tests to be positive, and then that would represent most likely you had an alkene or alkyne. Same thing goes this time around, okay? So you also need to test for alkenes and alkynes. That means everybody will need to do the bromine test, everyone will need to do the permanganate test, okay? Whether you have an oxygen-containing groups or nitrogen-containing groups, you'll need to figure out if you have that. We remember with the bromine test, like when it's turning positive, it could go on forever of you adding drops of bromine, it's still decolorizing. Stop that test at like 20, 25 drops. Most likely if you've got that far and you still have adding the bromine and it's still decolorizing, that's probably a sign of a positive test, okay? But to have an alkene or an alkyne, you also need a positive permanganate test. If you don't have them both be positive, it's not an alkene or alkyne. So both bromine and permanganate can give you positive results for others of these functional groups, okay? But the only groups that they will both test positive for is the alkene or alkyne, all right? So keep that in mind. All right, arrow ring. Do we have a good way to figure that out? Not necessarily with chemical tests, but we'll talk about here in a little bit other tests that you're going to use. So you have, IR is still one of your pieces of your toolbox, so you'll be collecting an IR spectrum of your unknown. We're going to add to that toolbox, you're going to collect a proton NMR spectrum. So we'll show you this week how to prepare that sample, and then we'll run the sample for you, but then you will actually work up the data for it. And then we also will collect GC mass spec data for your unknown, okay? And so with those three pieces in there is information that will help you figure out if you have an arrow ring or not, all right? The last piece, the halide, remember how to figure that out? Flame test. So you all need to do the Beilstein flame test too, okay? Now, that test just tells you if you have a halide or not. Does it tell you which one? No. But of the things I just mentioned, what would help you out to figure out which one you have? Mass spec. So what you'll need to review is if you believe you have a halide, make sure that you review what you look for in the mass spec to figure out which one is present, okay? And that was all coming from lecture information last time, all right? All right, so one of the new tests, chemical tests that you haven't seen yet is the copper sulfate test for amines. So this is the only chemical test for the nitrogen-containing compounds, is the copper sulfate test. And what happens if you have an amine present it will coordinate with the copper to make a blue or yellow-green solution. So you'll see the solution itself for copper sulfate is blue or turquoise green color. But if you get a positive result, you'll make this complex. And that complex results in a blue-green solid precipitate that forms, okay? And so that is what you're looking for. With the nitrogen-containing compounds, so this is our one chemical test you'll need to do if you have nitrogen. One thing you won't need to do with the chemical test is when we get to talking about solubility tests, because we will still do those like we did with experiment 6, you will not do a sulfuric acid test. Do not test the nitrogen compound for solubility in sulfuric acid. The reason is they can react very abruptly and with a lot of energy, and we don't want that happening in your test tube, okay? So you do not want to do a solubility test with sulfuric acid if you have nitrogen. And so then beyond this, for the nitrogen-containing compounds, beyond solubility tests and the copper sulfate test, you could do the Beilstein flame test, bromine test, permanganate test, but then beyond that, any other identification you're going to do is going to be based on your spectroscopic data that you're going to collect, IR, NMR, and GC mass spec, all right? And IR you will collect this week. NMR and GC mass spec, you will get that information next week, all right? All right, so now looking at this flow chart, okay, we've looked at what happens if nitrogen is present. Now we're going the other side, okay, so we don't have nitrogen present. The first thing we will do is a 2,4 DMP test, okay? And so if you recall from last semester, when you react either a ketone or this last semester we were just looking at ketones, this time we're looking at ketones and aldehydes. They will react with 2,4-dinitrophenohydrazine to give the hydrazone. And what you will see is it's the yellow-orange solution that then goes on to form the yellow-orange precipitate. So if you get a positive test for that, you will go on to do the chromic acid test. If you get a negative test for that, we're going to go on to the ferric chloride test, okay? So first we're going to look at the chromic acid test. And remember with DMP, and with all cases with these unknowns, wear gloves. They're more complex compounds than you had for experiment 6. There's more hazards involved, so you want to make sure, wear gloves, handle them in the hood. A lot of them have much stronger odors to them, so make sure you handle them in the hood. Like with all of the chemical test reagents, make sure that you are wearing gloves with them, okay? It's like DNP, if any of you experienced it last semester, turns you orange pretty quickly. You don't want to handle that without gloves. It also is made up in sulfuric acid, so you don't want to get it on you, and 2,4-dinitrophenohydrazine is not good for you either, so make sure you wear gloves. The next test you would do, if you get a positive result, is we got to determine, do we have a ketone or an aldehyde? Because all you have figured out with the DMP test is you have a ketone or an aldehyde. Chromic acid test will give you that information. So the chromic acid test reacts with aldehydes in a minute or two, and you get this kind of reaction that occurs, okay? So you go from your aldehyde to your carboxylic acid, and then you've got the chromium sulfate. The chromic acid is orange-red color. It's kind of almost looks like bromine color, and it's a solution, okay? So you have your aldehyde. You're going to add 1 drop of this to your aldehyde that's in a solution of acetone. And what you will get is a blue-green solution, and it starts actually precipitating out a solid. The aldehydes will react fairly quickly with this. Ketones will potentially eventually react, but they don't react right away. And so that's how you tell the difference, is you see a reaction quickly with aldehydes, and if you don't get a quick reaction, then it's most likely a ketone, all right? Now with the chromic acid, you need to definitely wear gloves, definitely handle it in the hood. You want to also be really careful with actually dispensing of it. It's very reactive towards all sorts of organic compounds. So when you put the one drop in your test tube, make sure you don't contaminate the dropper with any organic material. So you want to just make sure you drop it right over the test tube, not get any parts of the test tube on the chromic acid itself, okay? Make sure you have gloves on. Make sure you handle it, you know, be really careful with it. You don't want to get it on yourself, and you want to make sure you handle it in the hood, all right? If you have questions with this test, make sure you ask your lab prof, okay? Now, another key with this test is other compounds, like I said, are very reactive with chromic acid and can give false positives. So you want to make sure your DNP test results do a good job with that test. Make sure that you got a positive for the DNP test, and it wasn't something like acetone in your test tube or something like that that gave you the positive result. So don't cross-contaminate with acetone or any other possible ketones, or don't, all alcohols as well can give a false positive, and phenols. So just make sure you're really careful not to contaminate your test. Okay, so we finished this branch of the flowchart, okay? So if you have a positive DNP test, go on, do the chromic acid test, and you determine if you have an aldehyde or a ketone, you're done, okay? You don't need to keep going down this side. If you have a negative DNP test, then going down this side, the first test we're going to do is ferric chloride test for phenols. So you want to figure out if you have a phenol present or not. What other tests could you do on a phenol to figure out if the OH functional group was there? Ferric ammonium nitrate, right? The CAN test. The reason we do this test first, though, is because if you do the CAN test first, that just tells you you have an OH present, and it doesn't tell you if it's a phenol or an alcohol, okay? The ferric chloride test will react with phenols and not just regular alcohols that are not phenols. So that's why we're doing this test first. Rule out if it's a phenol. If you get a negative here, but then you get a positive for the CAN test, most likely that's not a phenol, that's just another type of an alcohol, okay? So that's why we're doing it in this order. So we reacted an phenol with ferric chloride, and we get this complex. The reagent is kind of a yellow-orange color, and a positive test is kind of a bluish red. It can be reddish or purple color. And so you're looking for a color change in the solution if you have a phenol. If you don't get a positive result, then what you're going to do, and it can range from red to green to purple kind of with that, is you're going to go on to the CAN test and do the ferric ammonium nitrate test, okay? And so for the test that you used in experiment 6, so bromine, permanganate, DNP, and the CAN test, all of the information as far as the experimental information for how to do those tests are in experiment 6. You won't find them in 18. So you want to go back to experiment 6 for those procedures to figure out how to run those tests. And make sure as you're going along and giving information for the test that you make sure you give what test is run, give the procedure that was used, and then give the results and what they mean. So you want to make sure you're keeping good track of your observations and the results, and not just saying, you know, this test negative, this test positive, because when it goes down to trying to figure things out, it's hard to figure things out if you don't have good observations. So with the CAN test, again, the CAN solution is yellowish, orangish almost, and you get a change to an orange-red color. So this is what you're looking for with that test, all right? So if you get a positive ferric chloride test, you're done with this side of the flowchart, you're done with doing the chemical tests, except for bromine and permanganate in your flame test. If you get a positive can test, or a negative ferric chloride but positive can, then you're done, okay, with the flowchart, and you just have to go back to bromine, permanganate, or flame test. If you're not done, then we're going to go on to the hydroxamine test for esters. And what happens there is there's kind of two pieces to this test. We are first going to take our ester and we have to react it with hydroxylamine to form the hydroxamic acid. But normally that's where we would stop. We form something different, we're done with the test. The hydroxamic acid, you can't see a difference between it and your reactants. So what we have to do is we add ferric chloride to it, and it forms a complex with the hydroxylamine, and then you get a purple color, which is then the positive result for the ester. This test involves a lot of steps, so you want to make sure that you go through it really carefully and make sure you follow all the steps, okay? Because there's a point where you add the hydroxylamine, and then you make things basic, and then you make things acidic, and then you add the ferric chloride to it, and there's an order of operations, and you want to make sure you're following everything correctly because there are a lot of pieces to it and you don't want to have to do it more than once, okay? So make sure you follow instructions carefully on this if you have to get down to doing the ester test. But in the end, when you add the ferric chloride, you're going to get this purplish solution, and that's what you're looking for a positive result for the esters, okay? After this test, there isn't any more necessarily chemical tests that we would do in the flowchart. The next step is we want to decide if we have a carboxylic acid or not, okay? So if you're negative for an ester, then you go down and you're trying to figure out if you have a possible carboxylic acid. The way you test for that is your solubility test in sodium hydroxide. And so you're just looking to see if it's soluble in sodium hydroxide or not. If it's soluble, then most likely you have a carboxylic acid. If it's not, then we went through everything, got negatives for everything, and that's where we're looking at for the ethers, okay? And so then we're done with the chemical testing. Questions on that part so far?
You get a negative for the solubility in NaOH, you still have to do the other solubility test.
You still want to do the other solubility test, but that's telling you what is pointing in that direction. So you want to do that to kind of confirm that you're at the ether stage. Okay. All right. So here are our solubility tests from experiment 6. So you're going to use the table from experiment 6. Still follow that table. You've got your you test for water, ether, 1 molar sulfuric, 1 molar hydrochloric, 2 molar sodium hydroxide. The 5% sodium bicarbonate comes into play for a few functional groups, not all of them. So in your lab manual, it tells you under solubility where you need to test for that. So in experiment 18, it lays out information as far as positive and negative results for solubility tests. If it mentions the bicarbonate test, then you would also do that one. And then concentrated sulfuric. And remember, if you have nitrogen, do not do that test. Okay, so if you have positive for nitrogen, do not do the sulfuric acid test, all right? And then, like I said, you're also looking for that flame test. If you get a green flame, then that's pointing at you having a halide, and you'll figure out from GCMS what halide you have, okay? Then we've got some data tables, and I'll put this PowerPoint on Moodle as well to help you remind you of things. Remember from last semester the IR data table that you're going to put together. That's still the same. It's on page, I believe it's 520 of your lab manual. It's still the same basic IR data table that you will use for analyzing IR. For NMR, we've got this table, and we've, like I said, I'll put the PowerPoint up on Moodle so you've got this for reference. A lot of this won't necessarily make sense right now with the first lecture that you've had, but as you go through the week and by the time you get to next week, a lot more of this will make sense as far as what's going into this table, okay? So just keep in mind for IR and NMR, you're going to be putting together some tables. And I'll talk about the unknown sheet you're going to use here in a minute, what information you'll put for GC and mass spec, okay? So this is the end here as far as the PowerPoint. I need to put up a couple things on the board for NMR and for mass spec. And then we're going to work through how you're going to figure out if you have a nitrogen and what and other information you're going to get from that. Okay. So things I need on the board are for GCMS, your sample prep. There's two ways you will prep a sample. There will be a liquid sample. You take 1 drop of your unknown, and you're going to put it, fill to the neck of the GC vial. This time we're using, instead of pentane, we used last semester, we're using dichloromethane, okay? So we're collecting samples for GC mass spec, but we're using the same vials as you did for GC, okay? So 1 drop in the vial, fill to the neck with dichloromethane, cap it, make sure you don't see any water or solid, anything like that, shake it up, make sure it's all mixed together. For solid, instead of the 1 drop, you're using 5 milligrams of solid, and then you're going to add the dichloromethane to the neck and make sure that that solid completely dissolves, okay? So we can't put anything on the GC mass spec that's a solid that is not dissolved. It has to be totally dissolved and make sure there's no signs of water. For NMR, and this will make more sense when we show this to you tomorrow, but the sample prep is if you have a liquid, you'll take 1 drop and dissolve it in our NMR solvent, which is CdCl3, okay? And you're going to use 5 centimeters of that solvent, and we'll show you in lab how you'll know that, okay? With a solid, you're going to use 5 to 10 milligrams, okay? And same thing, dissolving it in 5 centimeters of the NMR solvent, okay? So we'll show you this prep in lab, and it'll make more sense to you. For both of these, there is sample blocks to put your samples in, and then there's also, if you remember the sheets from last semester where you put your name, put your sample ID for submitting the sample, same thing will go for both of these, okay? Yes?
Do you want us to put the tables of the IR table and everything like in our notebooks or on that worksheet, or like attach it?
Definitely on that worksheet, but also it's a good idea with tables like that just to put them in your notebook as well. So you can check with your lab prof, but I would say to be thorough, it's always a good idea to put them in your notebook as well. For the other experiments you don't have a worksheet, you're always going to put it in your notebook, okay? Or in your final report. So before I talk about CHN analysis, which is where you're going to get your information about more information about what's in your compound, I'm just going to go through quickly. At the end of experiment 18 is a report sheet. There's 2 sides of it, okay? So don't forget that. You're going to fill out the information for your unknown CHN analysis. You want to show your math. I'm going to show you what the math means here in a minute. Solubility tests, results from chemical tests. And then on the back side, you give the physical properties and physical description of your unknown, and then it gives you information for IR, what information you need to put, give for the IR spectrum, as well as basically it's telling you to put the table in, report the table. Mass spec, it tells you what you need to report for mass spec as far as you're going to give base peak, identify the M plus peak, and then identify another fragment on the mass spec, and then NMR, it tells you information what you're going to use for NMR, but this doesn't quite make sense yet because you haven't really started looking at spectra to understand what we're talking about, okay? So just know this is on the back side of that report sheet. Don't forget about doing the back side. So there's two sides to that report sheet, okay? So for CHN analysis, what you are going to get, and we're going to kind of go through these problems quickly. These are the problems that are in your lab manual, but I'm going to try to explain them a little bit more carefully. You are going to get a piece of paper in lab this week that has your unknown number, and then it gives you percentages of carbon and hydrogen and potentially nitrogen on there. So that's why it's CHN analysis, because it's those three. So you'll have carbon, hydrogen, and if you have nitrogen, you'll also have nitrogen. That is how you will know if you have nitrogen or not, is by that slip of paper. So don't lose it. It's just a little slip of paper with your unknown number and those percentages. I'm going to go through a couple examples of how you're going to use that information to figure out what your empirical formula is for your unknown. So basically what the ratio formula is. It may not be like completely your exact formula, but it'll give you the ratio of carbon, hydrogen, and anything else that's in there, okay? So the first example has 77.4% carbon and 7.6% hydrogen in it and 15% nitrogen, okay? So the first thing to check when you get the percentages is, does it add up to 100%? If it doesn't, then there's something else that's missing, all right? So in this case, it does. So what we do then is we will get from our mass specs the molecular weight of your unknown, okay? You will take that information, okay? And so in this case, the mass spec, we've got our CHN analysis, and from the mass spec, our unknown has a molecular weight of 93, all right? So we'll take each of these percentages. So for carbon, 77%, 0.4%, which to multiply by the mass is going to be 0.774 times 93. It tells you how much of this 93 is carbon. So 72.1% is carbon, or sorry, 72.1 grams per mole is carbon. Take that and divide it by the molecular weight of carbon, and you figure out how many carbons you have, okay? So in this case, we have 6 carbons. For hydrogen, it's 7.6% or 0.076 times the 93, which is 7.0 grams per mole. Divide that by the molecular weight of hydrogen, and we have 7 hydrogens in there, okay? And then for the nitrogen, 0.15 times 93 is 14, and the molecular weight of nitrogen is 14, so 14 divided by 14 is 1. So therefore, our formula that we get from this analysis is C6H7N, okay? So you're going to have, based on this analysis, that will be the ratio of your formula, okay? You will keep that ratio. So this was a case where everything added up to 100%, all right? If it doesn't add up to 100%, then possibility there is either you have oxygen, in which case you won't have nitrogen, because we told you you'd either have nitrogen or oxygen, or you have nitrogen and or oxygen and possibly a halide, because that would be the other thing that's not going to show up, but once we do the math, we can figure that out, okay? So this is an example of where we have oxygen with example 2. So we have 70.5% carbon, 13.8% hydrogen. That does not add up to 100%, but we don't have any nitrogen in it. And we got a negative flame test, okay? So we don't have any halide present. So from these two, what is left unaccounted for is 15.7% of its mass. So we had a mass spec, molar mass was 102. So if we go through again, carbon 0.705 times, this time 102 is 71.9 divided by the molar mass. We have 5.98, which is pretty much 6 for carbon. Hydrogen is 1.38 sorry, it was 13.8, so 0.138 times 102, so that's 14.1 divided by 1.008 is about 14 hydrogens. And then we ruled out the nitrogen and we ruled out the halide, so the only other possibility is oxygen, which was 15.7%, so it's 0.157 times 102, that's 16, and one oxygen is equal to 16 as far as molar mass. So we have, oh, my oxygen has come off here, but we have 1.0 oxygen, okay? So, actually, sorry, it's just the 0 that's come off here. So the formula in this case was carbon was 6, hydrogen 4, and then oxygen 1, okay? So, okay so far? Okay. Then, the next example has where we're looking at something that doesn't add up to 100%. So what we're given is 64% carbon, 4.5%, oops, falling out of focus here. 64% carbon, 4.5% hydrogen, does not add up to 100%. We don't have nitrogen there, okay? And I'm going to tell you, for this example, we don't have oxygen, but the reason I have this example in here is to kind of get you to the next example to show you how to use the math, okay? And so we have 31.5% not accounted for. We know that we have a chlorine present, all right? And we know that our molar mass for the compound is 112, and so we're going to see how that chlorine comes into play. So our carbon, 0.64 times 112 is 71.7, ends up being 6 carbons when we divide that by 12.01. Hydrogen is 4.5%, so 0.045 times 112 is 5, basically divided by 1.008, so that's 5 hydrogens. And then for chlorine, its molar mass is 35, okay? So we've got 0.315 times 112, that's 35.28 grams per mole is potentially chlorine, and we take that divided by 1 chlorine is 1, so we get a molar mass of C6H5Cl. And the other clarifying part that we know is chlorine came from the mass spec, all right? So this, you wouldn't have an example here where you just have carbon, hydrogen, and chlorine because you're either going to have the oxygen or nitrogen. But this, like I said, this is getting us down to this final one that is more complex in math, okay? So we have 53.7% carbon and 3.2% hydrogen. That's all you're given for your CHN analysis, and it's not there. It's not 100%, and there is not a nitrogen.
So I'm a little confused about the order of the experiment, because aren't we supposed to do this first?
Well, you can't do this till you get your mass spec data.
But
So you won't be able to do this.
it's like the first step in the flow chart, isn't it?
You're not.
CHN analysis of the unknown is the first step.
Yes. Well, sorry. That kind of goes back to when we used to do something else instead. So this you'll get your information from mass spec next week, and then you can go through this process. So the CHN analysis used to be, it's a different test you used to do. You're not doing that test.
Oh, so different tests to do nitrogen?
Well, instead of telling you had nitrogen, there was another test that we used to do that we took sodium wafer and got it flaming hot and did all this tests with it, and then figured out if you had nitrogen or not. And so we don't do that test anymore. So that's where that came from.
So you guys are just going to tell us if we have
We're just going to tell you if you have nitrogen or not. So we're bypassing the really complicated tests where we would nearly catch things on fire, have flaming hot glass, and sometimes had to redo the test. Instead, we're just telling you. So you haven't seen this, but trust me, you're much happier that you're not doing this test. Because otherwise, everyone had to do that test. All right. So 53.7% is carbon, 3.2% hydrogen, okay? We don't have 100%, 43.1% not accounted for, okay? And we don't have nitrogen. We do have, we know from mass spec information, or from flame test, we have a halogen. We know from mass spec chlorine's present, and our molecular weight is 156, okay? So we're gonna work through here. Carbon, we work through the math. We get to 6.98 is how many carbons? So about 7. We work through the math for hydrogen. We get 4.95 or 5 hydrogens. For oxygen, we end up, kind of what you will want to do is probably go through and figure out, okay, chlorine, how much does that account for it? Let's see what 1 chlorine is. And then what we have left is we had 31.8% that wasn't accounted for with the chlorine or the carbon or the hydrogen. And that's where we go through and figure out for the oxygen. So, sorry, not 31.8, 20.4% was not accounted for. And that's what we multiply by the 156, get 31.8, ends up divide by 16, we get 2, okay? So in this case, where it gets more complicated, where you have the halogen and you don't have nitrogen information, but you have leftover information, you want to put together the carbon information as best you can, hydrogen, figure out what your halogen is, and then go back and use that information for the remaining piece to figure out the oxygen, okay? All right, questions with that? Okay, very last piece that you need. For the pre-lab, okay, it's a lot like experiment 6, all right? So you're gonna need a purpose. You will need the reactions for the new reactions that you have for this experiment. You will need a reagent table. And that reagent table should be for the chemical test and the solubility test. What reagents you're using for solubility, what reagents you're using for the chemical test. And that's saying you could potentially have any unknown, all right? Then you have the flow chart, which I've shown you what that flow chart is, okay? And then the last piece is your reference. There isn't any really new equipment to show. Like we have a GC mass spec, we have an NMR. There's not really a good way for you to draw that as far as new equipment. So there's not a new equipment piece, and there's not a yield piece because you're not calculating a yield for this experiment. So these are your 5 pieces for your pre-lab. Yes?
Okay, so we don't need to write this standard calculation on your
No, like eventually show those calculations in your notebook, but there's not really a good way to do a sample.